Our last topic is also attractive, which relates to next generation test. Angie graduated with master degree from Multimedia University, Malaysia. She is technical lead for Intel Malaysia IoT Group, as well as a certified FUSA automotive engineer. And today, we have SG online for the Q&A. And SG holds several technical positions throughout his career in Intel, and his current position is a staff technologist and product owner for Global Post Silicon. Okay, let's welcome Angie.
Hi everyone, my name is Angie, and together with me, who will be co-present today is SG, and we are actually from Intel Corporation. So for today, we're going to share with you the next generation test cell and test operation. So first and foremost, what's actually the importance of a power sequencing test that I will go through with you, and then followed by what's the methodology to perform the test and the cost involved when we conduct all these tests. Of course, I also walk you through the overview of the solution, followed by the sample test result to show you, and then wrap up in a summary with the impact of the power sequencing tester, and end with the acknowledgement. All right, so without further ado, let me move to the next point. What is actually power sequencing test? Well, when you look at a system on chip block diagram, right, besides the CPU, we actually have many other blocks, for example, GPIO, display MIPI, memory, and ADC. So it's really important for us to make sure that every signals or power rails in this whole block diagram is working well and functional. So in order to make sure the product is reliable and functional, right, we need to check the power rails, for example, the 3.3 volt, 5 volt, or the power good and reset signals for the PMIC. So these are all the important signals in timing sequences. In fact, for power sequencing tests, there are two different timings or voltages that we focus on. One is when it first turn on the system, right? So you will measure the power up sequence, and then when you power down or terminate the SUT, we will measure that power down timings and sequencing. So all this is critical to ensure the product functionality and also reliability. So next, how do we perform power sequencing tester, and what is the normal conventional way of measurement? All right, so in first scenario, if let's say we want to check 32 power rails signals, um, and then we have these 8 channels of oscilloscope. So we may need 4 channels. We may need to repeat the test 4 times with different signals to make up the 32 power rail signals. So this we need um, 4 oscilloscope, and then with 1 time test cycle. The the worst case scenario is like we need to cascade a few different test cycle, which means like if we only have uh, 2 oscilloscope, okay, so you need to measure it in such a way that you need to repeat it 4 times, this testing or measurement cycle, in order to get 32 signals from the measurement. So if there is um, I mean, if the measurement is taken over different or multiple power cycles, right? So this will cause a different variation, and it's not accurate in our device characterization. Okay, how much cost? Maybe you wonder to conduct the power sequencing tester. In normal case, we need the oscilloscope the 8 channels oscilloscope may cost around $50,000. So if we need like 4 of them, it's like already $200,000. And then ours, we need to rework the boards for this type of measurement, and it will take up like hours to do the pre-work before we can conduct the power sequencing test. And then of course we also require technician or engineer headcount to support and measure through the oscilloscope. So what we found the variation here is, for example, because it's using human touch and also depends on engineer and technician, right, to do this manual characterization and human eyes to judge the measurements. So the results or the accuracy may vary, depends on the experience of the technician or the engineer. So I would say that the current limitation as shown here, the execution time is lengthy, and we need all these high costs of oscilloscope to perform the test, and it actually may not come with an accurate test result because it involves human measurement handling, and the repeatability test is not it is causing all this inaccuracy. So without the and for the conventional way, physical touch is needed there. Okay, so what's leading to our innovations? There are few things that comes from users that they will ask. What if we can increase the number of channels in an oscilloscope from 4 to 32 channels or maybe more? What if have an agent that can help on the technical judgment, whether the result is pass or fail? What if I can eliminate the physical touch in validation setup and do it remotely? And the user also want something like they want us to help them compile the technical report. So all these demands actually leading us to the objective of automate power sequencing tests, and with this innovation solution. The solution overview. So in short, right, actually we are using the FPGA, which is a field programmer gate array, to construct this customized multi-channels up to 36 channels of tester to perform power sequencing tests. And then all the test result actually are captured and compared to the predefined recipe, which means we can predefine the design power rules and then determine the pass or fail condition. So we can actually auto generate a HTML or PDF report and detail out those signals and result summaries. So with this, right, actually from the platform measurement using this power sequencing tester, and we just need like a debug host or PC there. So more detail on the in terms of hardware specification, this power sequencing tester can measure up to 1 megasample per second sampling rate per channel, and it has 36 signal single-ended channels, and also it is a 8-bit resolution per channel with 1 meg ohm input impedance. And there are actually 3 different types of input voltage ranges from 0 to 5, 0 to 20, and also plus minus 10 volt. We can actually capture a duration of data up to 1 minute per channel. And then the simultaneous sampling, right, we can, with the same clock, is possible for all the channels. And we can select one of the single channel edge triggering. Either we can set it as a rising or falling edge, and with the flexible adjustable threshold voltage. User can also select the trigger position, either from 0 to 99% of the total capture signals buffer. All right. So on the other hand, in terms of software specification, we have a user-friendly GUI which can load the configuration file, the previous configuration file, can save your existing config file, arm or disarm, which means like start or abort the system easily. And of course, it can also generate the reports or save your waveform data file and then export out for presentation and so on. So all individual waveform display, right, for each channel actually comes with zoom features, either vertically or horizontally. And then we also can set a change to the advanced control or setting for any waveform display that we select. And the timing of capturing all this data, we can actually set it accordingly, and up to 1 minute of duration. So user can predefine all these pass or fill voltage and timing condition with the design rules import in. And of course, the voltage rule checking also is one of the feature. So we can check both voltage and also the timing specification. Besides, here is how we actually set up the profile or recipe configuration. As mentioned, there are 3 voltage ranges, and then we can set the timing checking rules and voltage checking rules based on the diagram of power up or power down sequence, right? So uh, 2 signals, they may have a timing spec that govern these 2 signals, and we need to meet this spec. So we can call out this specification in the timing checking rules. And voltage is, for example, maybe 3.3 volt. You have the upper limit and lower limit, for example, plus minus 5%. So you can actually set up in this GUI as well. Edge detection for timing check is also one of the feature, and user specify triggering channel with either rising or falling edge. For voltage threshold and voltage delta selection, yeah, you can choose what is the threshold voltage that you like to have the trigger on. So all this, once you set up the profile, you actually can just click on the button save, and all these setting and details are actually saved in the GUI that you can call out later in the stage. All right, I'm going to show you is the sample of one of our test result. So the graph on the left hand side is the summary page, where you can see the timing check and also the voltage check, right, that show a past result now. And there's 3 different graphs that we measure here. For example, the RTC reset, the PMIC signals, and power OK, and so on. And you can just zoom into all these graphs and see in more details. And under the options, you can also choose like from channel 1 to channel 6, which channel actually you're interested in. So in this case, we actually check all these 6 signals and it display with different colors. And you can measure, you can see how the voltage ramp up and how much time that it actually went out. Okay. Then let me show you the sample recipe configuration where you can actually set it up in a spreadsheet, an Excel spreadsheet, or you can directly enter in the GUI with all this recipe configuration. So from the Excel, you can import in and they will actually recognize and convert the format to the configuration file. All right, if not, then you can just open up the configuration tab in the GUI and then key in the name of the voltage and whether want to enable this means whether want to have the measurement on these channels, and then choose one of the channel as a triggering point. You can choose the edge as rising, falling edge as shown in the screenshot here. And then down there, that is the timing rules where you can choose first channel and second channel. In this case is channel 9 and 10, so then we can do a comparison that the timing spec should be 10 millisecond in this case. All right, let me move to the test report. So once the measurement is done, it will auto generate this HTML report, and you can see that it will mention about what configuration file, whether overall result is pass, and then voltage timing, is it pass or fail, and you create a table where capture all the previous the specification that you have entered before for voltage or timing, and provide you a column of results. Okay, so it's a really simple way to auto-generate the report. Then let me show you how we actually set up the power sequencing tester. It all started with a small little NUC that connect by USB to the power sequencing tester. From the power sequencing tester, actually there are probers. You can use this 5i connectors, or actually you can also use 40 pins Semtech connector to directly plug on the board itself, either with a connector, or in this case is actually using a pin header to connect all these signals. So now this is the system under test. Once it captures all the data, so you can observe the results in the GUI easily, and then auto-generate to a report that you can send over to your stakeholders, managers, and others. All right. So this is a very simple, fast, and accurate way to measure so many signals that you need in the power sequencing. In summary, right, want to stress on the return of investment or the impact for this power sequencing tester, and how much improvement that it can bring to us by using this power sequencing tester. So the hardware cost saving is around 78%, test time 99%, and headcount, the characterization method and results is actually 100% improvement. So why is it has so high of the improvement, right? Is because we eliminate the human dependency and improve this test quality and time. So this help us in significantly in the business impact, where it strengthen the Intel and customers engagement in a fast, secure, and automated way. So I would say that in summary, this power sequencing tester bring us a competitive advantages in terms of quality, accuracy, and speed in the world of validation. Towards the end of this presentation, I'd like to take this opportunity to thanks Eric Chan, our Malaysia Design Center, KH, and others that on supporting us to realize these innovations of power sequencing tester. So with this, I end my presentation and thanks everyone.
Great, thanks, Angie, for the presentation. Let's wait for the question from the audience. Before that, I have some question here. Hi, SG. How long you have been doing this?
You mean for this particular project?
Yes.
I think from the design concept until into production, I think it's about 2 to 3 quarters of time. Yep.
Okay. And how many DUTs in parallel you can support?
It actually depends on the target system or the system of the test that we are dealing with. You know, for example, if let's say because the system is designed to cater up to 36 channel of the input, and then it depends on how many channels of DUT from the from the DUT or the SUT that you're working with. Then you can just connect it, set the voltage rules accordingly. And of course, bear in mind that there's only one trigger channel here, where maybe you can do multiple sync testing across different DUT or SUT, but it depends on the configuration, how it goes, you know. Yeah, but I would say that it's kind of flexible, that the whole concept is actually to turn the bench testing into an automated way. Because I think in some of the semiconductor industry, we're actually dealing with those system under test. It's not just the DOT only. So I think that's actually cater specific use cases here. And we have wanted to showcase how we can do this in a more automated way in terms of saving the times and improve the accuracy of the testing. Yeah.
Okay. So what can be done these ways? Anything that still requires a technician?
In fact, you probably just need a technician to actually help you to connect the probers onto the system. And then once the connection is established, then you can just power on the system. In fact, we can do that remotely to power on the system. And then the device will actually capture all the measurement and do the auto calculation based on the profile or the rules that you predefine, like the recipe, things like that. And then you'll come out with the result for you. So we did say that it's actually eliminating those technician support from time to time to actually change the probers, because if you are using the ordinary oscilloscope to do this bench testing, right, probably you need to switch the prober from time to time from measurement to measurement. And then later on, probably the technician needs to extract out the test result, the waveform, everything. And probably we need to do some naked eye testing or judgment based on the result, you know. So all this work is actually very heavy duty, involve a lot of human interaction in the entire testing. But with this system, we actually managed to eliminate all the support to run this test, you know.
Okay. So since no question from the audience, so thanks again for the great sharing. Thanks.
Yeah.
We want to thank our sponsors once again, Test Tooling Solutions Group as our premier sponsor, JDT Technology, our honored sponsor, our distinguished sponsors, Nidec SVTCL, Smiths Interconnect, TSC, and Feldman Engineering. And a reminder that you can reach out and contact them through the website, through the chat or message buttons there. So please take a moment and thank them and reach out and ask them about their products and services. I'm sure they will be very happy to help you. And also I want to thank our media partners, ACT with Silicon Semiconductor China and EE Times with an upcoming Double Summit event next month. So you can find links to this on our website. And then an extra special thank you to Test Tooling Solutions Group being our premier sponsor. Certainly a lot of innovative solutions there in this space of test equipment and test consumables. So please thank them once again. And lastly, I would like to thank all of you for participating in TestConX China. It's been a great pleasure. I'd like to thank the authors and the committee, but most importantly, thank you for joining us. We hope that you found this to be informative and useful, and certainly appreciate any feedback you may have. We look forward to seeing some of you at TestConX in May in Mesa, Arizona, and then TestConX China 2021 in the fall in Shanghai again. So thank you. Have a good rest of your day.